Welcome back to the studio. Today we have Yuri and me, and we're going to do a little calculating eccentricity. So you've got this ellipse, not a circle. It looks squished as we go around. Okay, and you have an asteroid going around the sun, or a planet going around the sun. There's some different things that you have to be able to do. Oh, thank you, Yuri. First thing Yuri wants us to be able to do is measure the distance between foci. So you get your ruler. The foci are these two things. If you're creating it, there's going to be two holes there because you put tacks. If you're just measuring, you've got to go to the nearest tenth. And to me, I'm not crazy about this ruler because it starts right at the edge. Remember, if there's a zero, you got to start at the zero. It looks like about 2.2. So my distance between foci is 2.2, and you got to have your units centimeters. Okay. All right, Yuri, what's next? Yuri says length of major axis. You go right through. So this is how long your ellipse, your oval, your not circle is. You go from one edge all the way through right to about there. Get the glare. Ooh, looks like it's right on 8.5. So length of major axis is 8.5 centimeters. Okay. Next, what do? We calculate. So you have to divide the two. You can put it into your calculator. Me, I use Siri. Hey Siri, what is 2.2 divided by 8.5?
The answer is approximately 0.2588.
259. Thank you, Siri. So that would be my answer for eccentricity or eccentricity. You have to round to the nearest thousandth for that. And you have to round up or down based off of that last digit. So there's always going to be 3 digits there. If you forget what the eccentricities are supposed to look like, they have examples right here in your ESRT. And then we can do a last thing is we can compare our asteroid compared to, let's say, Mercury. Mercury's is 0.206. There's no units because the centimeters cancel out. Which one is more elliptical? Here's how you do that. 0 and 1. Which number looks like a 0? No. Which number looks like a circle? 0 looks like a circle. Numbers that are closer to 0, smaller numbers are more circular. Numbers that are closer to 1 are more stretched out, more elliptical, elongated. So the bigger the number, the closer to 1. That's the biggest number you can get. It's always going to be a decimal. The bigger number, closer to 1, is more elliptical. The number closer to 0 is more circular. So this would be more elliptical, our asteroid, and the planet is more circular, smaller number. Make sense? The last skill you have to do, if you were to locate where is this planet going the fastest, where is this asteroid going the fastest, you'd have to know where the sun was. The sun could be at either one. Let's say the sun is at this one right here, the star of the orbit. Where would the planet be going the fastest? Where would the asteroid be going the fastest? On the major axis, closest to that star, closer together, more gravity, so it goes faster. So the planet would be going slower, 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 faster, 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 until right there. So that sums up all the things for calculating your eccentricities of orbits. He doesn't have anything good to say. I don't know. He ran out of jokes. I'm going to stop the video.